So the second part, what I want to talk about is aggregation in MongoDB. So in the SQL, when we talked about the relational database, we also talked about some aggregation functions in SQL. So similarly, MongoDB also have some aggregation function, but it's actually very powerful in MongoDB. So in most of the times, when you code like a query in MongoDB, you will be likely to code aggregation because it's a powerful function and which is able to do many operations here. So basically, aggregation framework in MongoDB is like this. It will transform and combine documents in a collection in a way you specify. So it's similar to aggregation in SQL in some way. And the aggregation function in MongoDB, it can be coded like this using the aggregate function. So basically, you specify the DB, current database, dot collection, the name of the collection you want apply aggregation. And then you specify aggregate function, and here you specify a number of operation as a list. So you use the list format, and inside here you specify a number of operation you want to perform. So basically what you are doing is that you are making a pipeline that processes a stream of documents through several operations. And the operation you are able to use in the MongoDB are these: filtering, projecting, grouping, sorting, limiting, and skipping. So I go this one by one to make sure that we are all in the same stage. So this is the MongoDB aggregation framework basically. So you have a collection here which is specified. This collection will have multiple documents like this. So from one collection you specify there are multiple documents, and you will specify multiple operations in a list, and this document will go to the first operator and it will be processed, and after that the results will be sent to the second operator, and the results will be sent to the third operator, and the final results will be shown to you like this. So in this way basically you are making a pipeline of multiple operators inside the aggregate function. So the first aggregation function, the first aggregation part that I want to talk about is the filtering. Basically you can use filtering by utilizing match operator. So it's basically same as the query. So you use match operator and you specify the query you want to perform. Then in the aggregation function, it will filter documents to select a subset of documents based on the query operation you specify inside the query part. So last time we had this CD collection which we made inside the MongoDB, which contains a zip code in the United States with the population information. So let's try to practice something here. So basically, when you design the aggregate function, this is the format. So you specify db dot collection name cd in this case, and dot aggregate function, and open bracket, and also you have to open the list bracket here, and inside the list you specify multiple operator. So in this case, if we want to select all the zip code with a population more than 100,000, we don't need to use any other operator. We'll simply use one operator, which is a match operator, and the condition here you have to specify. The query is population should be greater than 100,000. So basically this part, the query part, is exactly same as what we talked about last time in the query part. So you simply use the same query right after the match operator. So that's how you do. So this is very simple. So if I copy this and put it in a MongoDB, then yeah, you will see the results. So it's the same as last time. So basically there are 4 zip codes which has a population more than 100,000 in the US. So that's the match operator. Basically you use query to filter documents. The next operator I want to talk about is a project operator. Basically it's the projection. What it means is this: you use the project operator like this, and you specify the expression, which I'll talk more about it. Basically, by using project operator, what you can do is extracting or rename the fields, and you can also perform some operations on the field. This is much more powerful than normal query because you can do something extra here. And the type of expression you can perform using project operator are these things: pipeline expression, mathematical expression, date, string, logical expression, which I'm going to cover briefly. The pipeline expression is this. Basically, if you remember last time in the query, we also had like a similar function. When you get the results by using the find function, you can specify the query and you can specify the returning rules. So you can specify which field can be returned, which field cannot be returned, something like that. A similar thing here. You can decide to include or exclude certain field in the result. So you can specify field 1, then either include that field in the returned result. If you specify 0 in the field, either exclude that field in the returned result. Also, you can specify the existing field by using $sign and the name of existing field and double quotation on the front and the back, like this. So if you specify the existing field like this, you can do something about that. So you can rename the field. You can put the new field name and you can put the existing field name like this. Then in the returned result, all the field name will be renamed into the new result. So if you use the aggregation, the returned result, the name might be changed. However, in the original document in the collection, nothing will be changed. It's just, you can just make changes in the returned result. So let's try this simple example based on what we just talked. So again, we want to select all the zip code with a population more than 100,000. But in this time, we want to make sure that we want to rename ID field into zip code field for better visualization, and we want to return only zip code and population information only, so that it's easier to read the data. So in this case, again, it's an aggregate function, so we specify db.cd.aggregate, and here we have to make sure that we open the bracket for the list, and inside the list, we specify multiple pipeline operation. The first operator we can use is match. So we use the match operator, and we specify that the population should be greater than 100,000. So that's the filtering using the match operator. And after using this match operator, basically we filter documents, and I put the comma to specify next operation. The next operation is a project, because we want to rename the field in the result. So use the project field, project operator, and then we want to make a new field name zip code, which will replace old field name ID, like this. And the old ID field I don't want to show in the result, and I can also specify that I only want to show the population field by using 1, like this. So basically, using the project operator, we are specifying 3 things here. We want to make a new field zip code in the returned result, which will replace ID field, and also original ID field we don't want to show, so we specify 0. And for the population field, we want to include in the returned result, so we specify 1, like this. So that's it. So we copy this, and we can try here, and then the results will be like this. So it's the result is exactly the same as earlier, but we can see and read the results much easier because only 2 fields are returned here: population and zip code. Population, zip code, like this. So basically, by using project operator, you can make the field name much easier to read, and also you can reduce the size of the document. which is quite important because in the big data, in the big data management, most of the document size will be actually quite huge in the real world because it contains multiple information. So when you want to do a certain operation on the big data, it's better to prepare smaller number of documents and smaller size of documents before you process something. So practically, projection and this project operator is quite useful in terms of increasing the speed of your operation. And also, there are multiple mathematical expressions you can perform. So all the operators are listed here, so you can utilize it later. So basically, to use mathematical expression, the format is this. You can specify the new field, basically the field which will contain result of a mathematical expression. And then you can specify the math expression here. So basically, you can manipulate numeric value using the math expression. And on the math expression part, you can utilize these expressions here. There's add operator, and then you can specify a list of number elements. Then this add operator will add all the elements in the list. There's a subtract operator, and you can specify 2 elements in the list. It will calculate expression 1 minus expression 2. Multiply, similar. In this operator, you can specify multiple elements in a list. It will multiply all the elements in the list. Divide operator, you can only specify 2 elements in a list. It will divide expression 1 by expression 2. The last one is the mode operator. If you are familiar with the programming language, you probably have heard about the mode operator. Basically, it will give you the remainder of dividing the first element by the second element. So those are basic mathematical expression you can utilize in the MongoDB. So let's see this simple example. So I'll not try this in the MongoDB. You can try this later. So basically, the first 2 lines of this code, what I'm doing is that I'm preparing staff collection with the 2 documents. First document, name, Tom, salary, bonus information is here. Second document is about the Jane. Salary information, bonus information is like this. So we want to calculate the total pay of each staff. So basically, we want to calculate salary plus bonus. Then you can use the project operator together with the mathematical expression. So in this case, we can start with project operator. So earlier, if you use the project operator, you can create a new field to store mathematical expression result. So we make a new field named total pay. And total pay should have the result of adding salary and bonus. But the salary and bonus is not just a number. It's we have to refer to the this field name because the value of salary is different for everyone. So we have to refer to this field name. To refer to field name, what we talked about this earlier is this. If you want to make a reference to the field existing in the document, you have to use a double quotation on the front and the back, and you have to use the $sign, and you have to specify the name of the field. So I specify salary like this, then it will refer to the value stored in the salary field in each document. Same for the bonus. Like this. So that's it. So this is simple code. So basically we use the project operator here, and we make a new field named total pay, and total pay field will be calculated by add operator. What we are going to add is basically the value stored in the salary field and the value stored in the bonus field. So for the first document, we calculate 80,000 plus 20,000. It will be saved into total pay. For the second document, same, 70,000, 25,000. It will be added together, saved into total pay field for the Jane document, like this. So that's it. That's how you can utilize project field to perform mathematical expression. Okay, so let's go to the next one then. So next one is date expression. So you can also sometimes you may have some date variable and date information stored in the field. Then you can use some date expression. So it's similar. So you can specify the new field which will contain the value from the date expression, and you can specify the date operator, and you can specify the date field. So you can extract the date or time related number from date type fields basically. So this data expression will receive data as input and return number as a result. So that's the main function of data expression. And data operator you can utilize are many things. You can see here there's a year, month, week operator, day of month, day of week, day of year, hour, minute, second operator. It's all available to use. So basically you can extract each number from the date and time information. So again, let's try this. So again, you can try this later. I just show you the solution. So here again, I prepared two documents, the staff collection, and I made two documents. One is name Tom, one is name Jane, and hired I put new date. So just to show how this works, let me actually try this on the MongoDB. The first one here. So I tried the first code first. So I tried this. Right now my time is 11:19 a.m. So I tried this code at 11:19 a.m. And let me try this code 1 minute later, so that I have some time difference between these two. Okay, so now it's 11:20. So let me try this code. Okay, and then let me refresh test database, and then there's a staff collection which we just created, and I have two documents here. So first is about Tom. He was hired at oh yeah, the time is actually slightly different because it's not following my time. I think it's a standardized time, but anyway, so it's 3:19. The second person, Jane, is hired at 3:20, like this. So there's a time difference. And let's say that we want to calculate how many minutes has passed since the staff hired. Then we can extract this minute information from the hired date, hired time, and we can calculate the difference against right now. So to calculate this information, we can code like this. So let me show you the code first. Okay, so this code should work. So let me explain a little bit about this code. So basically, again, I used the project operator in this case to perform mathematical expression and also data expression. So I used the project operator and I created a new field called the minutes passed. So how many minutes passed? And to calculate this information, I use a subtract operator, and in the list I specify two fields here, basically two elements. First element is the minute extracted from new date. So whenever you use new date, it will calculate the current time in your PC or server, and the minute will be extracted from there. And I used, as a second element, I used the minute operator with the hired field. So hired field exists in each document. So the date inside the hired field will be extracted here, and we will take only minute information from that field. So basically it will calculate the minute of current time minus minute of hired time. So we can perform this to see how many minutes has passed since we added two of those information here. So copy this here, and if I perform this code, then here the information is given. So yeah, so it's correct. For the first document, 4 minutes has passed. Second document, 3 minutes has passed. So it's consistent with this because we added the first document 1 minute earlier in the beginning. So that's it. So that's basically one simple example of how we can actually utilize this data expression. Okay. So also there is a string expression. So you may sometimes have a string like a data type. Then you can use this string expression. The format is the same. You can specify the new field which will have the result of the string expression. And for string expression, you can use a substring, concat, to lower, to upper. So again, if you are familiar with the programming language, this kind of a function will be familiar with you. But if I give you a brief explanation, for the substring, you can specify 3 elements in the list: expression, start, number. Basically, it will return the number of characters you specify here, starting from start position from expression, which is a string data. So it will basically take the substring from the middle of the string data. There's also concat. So concat, you can specify multiple elements inside the list, and basically it will combine all these elements in the list into one. There's a to lower, to upper, making string into uppercase or lowercase. So that's all. That's all for the string expression. And okay, here's one example here. We can try really quickly. So we want to select all zip codes with a population more than 100,000, and for better like readability, we want to return its address information with the following format: city, comma, state. Then for this, we can design this aggregate function. So first of all, we can use the match operator as we did earlier. So here basically we select population greater than 100,000. So that's the first operation. The second pipeline operation we can give is the project operator. And we want to create a new field, address. And address should be in the format of city, state. So we use the concat operator first, and in the list we specify a number of string elements. The first one is a city. So every document has a city information. So we use $cd and double quotation to refer to the value stored in the city field. And then also we need a comma. So add a comma here. And then so we want to show the city, comma, and state. The last information is state. which is stored in the state field in the document. Oops. Okay, like this. So that's it. So basically, yeah, this kind of like referring to the original field is used quite a lot when you use aggregation. So in this case, we use cd, the value stored in the cd field, and comma, the value stored in the state field, and we put them together using the concat operator and save it inside address field. So that's what we do. So let me copy this. And let me test this in the here robo3t. If we perform this, here is the result basically. So zip code 10021 is in address neo, comma, ny. So we made this new field in the returned result like this. So that's it. That's how you can utilize a string expression in the project function, project operator. There's also logical expression you can utilize. Basically, it's like comparing two different values. So also for the logical expression, you can use the same format. So new field and the logical expression later. And there is a comparison operator, CMP. Basically, you can specify two elements inside the list, and it will return 0 if expression 1 is exactly the same as expression 2. Basically, it's comparing this and this. And it will return a negative number if expression 2 is bigger than expression 1. It will return positive number if expression 1 is bigger than expression 2. There is also string case comparison. It's similar to the comparison operator, but in this case you will specify two strings in the element, and it will do case insensitive comparison for strings. Basically, in this case, it's the same. String 1 is the same as string 2. It will return 0. Otherwise, positive or negative number. There's also a conditional operator. Here you can specify expression 1 and expression 2, and using the conditional operator, you can do some operation here. So this conditional operator here, what you can use is basically exactly the same as the conditional operator we covered in the query part. So equality, not equal, greater than or equal, all these operator we can utilize here too in the projection function. So it will also perform comparison based on what you specify and either return the result as true or false. And other logical expression we can utilize is something like this: AND operator, OR operator, NOT operator, which we already talked briefly about when we are talking about the query part. We can use those operators exactly in the same way here. So I'll skip giving more detailed examples on that part. You can try this later by yourself. And another operator you can use is a conditional operator. So if you are familiar with the programming language again, conditional operator is exactly the same as an if statement in Python or other programming language. So basically, conditional operator, you specify expression and you specify true expression, false expression. What it means is that if the first expression you specify, if it is true, the result of the second one element will be returned. If the expression is wrong, false, then the last element here will be returned as a result. Okay, so that was all about the projection. And the next operator you can utilize in aggregation, which is a quite powerful one, is the grouping. So it's a group operator, which is quite similar to the aggregation operation in SQL. So in aggregation, we talked about sum and average, those kind of operation. It's exactly the same. So if you use a group operator, you have to specify grouping and combining. Basically, you have to specify how you want to group documents by certain criteria, and you have to specify how you want to combine their values inside each group. So basically, you are specifying how to group, how to calculate. In grouping, what you specify is this. You specify ID. So based on the ID you specify, it will make a group. So those documents which has the same ID will be assigned into the same group. And for ID, you can specify the existing field using dollar and quotation mark. So I'll give you some example later. Basically, you can use an existing field in a document to make a group ID. And the combining, here is the place you specify how to calculate information in each group. So you specify the new field which will save the information, and then you specify the combining operator and expression. So then it will perform combining operation on expression for each group. An expression can be a value or an existing field. And the combining operator here, what you can use are these things. Basically, almost everything, almost every possible calculation. Sum operator, average operator, max, min, first, last operator. And there's also, you can utilize the add to set operator and push operator if you want to create a list as a result of the grouping, basically. So let me give you one example here. Actually, the best way to see how it works is by using an example. So what we want to do here is this. Again, earlier we had the CD collection in our MongoDB, and CD collection contains zip code information across the 4 major cities in the US. And we want to know how many zip codes exist in each state in our dataset. Then you can design this function using aggregate function in the MongoDB. First of all, we have to use the group operator because it's the aggregation. And in the group operator, the first information we have to specify is the ID. So ID is basically based on which information we are going to make a group. So basically, we are calculating how many zip codes in each state. So each state is a group, basically. For each state, we want to calculate something. So state information is stored in state field. So we specify state field will be used as new group ID. So we specify that. And in the second part, we have to specify how information will be calculated. We want to know number of zip code, basically. How many zip code exists in each state. So let me shorten number of zip, basically. And how to calculate this? So in relational database, we had a count operator, but in the MongoDB, we don't have a count operator. So what we can do is that instead of a count operator, we simply use a sum operator and we sum number 1. So what it means is that for each document, we'll give number 1. So if there are 100 documents in state of New York, each document will be 1. So we sum up, then it will be 100. So that's all. So we close the bracket and close the one more bracket, then yeah, that's it. So the code itself is quite simple. We simply use the group operator, specify the ID, which is a state, and for each state we calculate number of zip code by using sum operator. So I can copy this and try this in the here MongoDB, and if I perform this query, yeah, then it gives some information. So actually there are some state which yeah, we didn't want to see, but it's also shown here. But anyway, there's a New York. Currently there are 1,595 zip code. Texas has 1,600 zip code. California 1,500. Illinois 1,200 zip code, like this. So that's what we have in our dataset. So that's it. Okay, so any questions so far? Oh, you mean the order? Actually, we are going to talk about that later. Yeah, so there's also sorting function which we can utilize. Yeah. Okay, so
filtering the group by how to filter the group by
how to filter?
yeah. How to filtering that for example the number of zip code I want to have a state that over 1500.
Oh, I see.
How can we get that?
Let me see. Actually, yeah, that's a good question. So we are going to talk more about that later, but if I give you like a brief example, something like this. So basically the aggregate function, when we use it in MongoDB, we are making a pipeline-able operation. So if you want to, so for example, in our result here, we have a multiple state and we have some state which is included by mistake, right? There's only one zip code in these two states. So we want to show those of state when their number of zip code is only over, at least over 100 or something like that. Then after this, you can add one more operation here. So in this case, it will be match operator because we want to filter the result, right? So we can use the match operator here, and as a the query, we can use a number of zip because we just calculated from the earlier operation, and it should be greater than 100 at least, something like that. So if we do that, so let me see whether it works first. I just improvised this, so I'm not sure whether it will work correctly, but yeah, it works. So in this way, you can do filtering basically based on the results you created. So basically, aggregate function is that you can add as many as operations possible. So if you want to do some complex aggregation, you can add more operation to achieve your goal basically. Yeah. So that's one example. Yeah.
So for another way functions, we can use the column name that we have been created or declared in the previous aggregation operation.
Oh, so sorry. What do you mean? Yeah.
So there are two operations
here
in this other way.
Yeah.
For the follower aggregation operation. So the field name that I can be used is the one I have assigned or created or declared in the previous one.
Yeah, so basically, so after the first operation, the results will be returned, right? The list of documents will be returned, and each document will include a certain field. So those fields included in the returned documents can be used in the next operation. Yeah. So in this case, I only include two fields as a result, so I can only use these two fields. But if you add more fields, then you can use more actually. So for example, yeah. So if you want to utilize other fields, you have to make more. Yeah.
So let's say if I want to use the field that does not appear in the previous one.
Yeah.
And I cannot use it in the further one.
Because in this case we are using grouping operator, so previous fields will be removed actually. Only ID field and the new field will be remained because I'm using group operator. But if you use other operator like which doesn't use group operator, then the original field will still remain. Then you can still use it. Yeah. So you have to check which field will be left after each operation. Yeah. Okay.
Can you specify multiple IDs?
Multiple ID?
Not grouping. Like can I group state and city?
I see. I'm not sure, but my intuition is that it may not be possible. Yeah, because ID, based on the MongoDB definition, ID is like a unique information for each document. So I don't think that's possible. If you want to use CD and state together, you can use the concat operator as we did earlier. So in the concat operator, you can use cd and state and combine it, and then you can use it as ID. So that's one way. Yeah. Any other questions? Okay, so yeah, so let me go to the next one. So this is one example here. Next aggregation operator I want to talk about is unwind. Basically, it's unwinding. It's an unwind operator. What it means is that we can have a list data type again in the MongoDB, and a list will contain multiple elements. And if you use an unwind operator, and if you specify those list fields, basically it will turn elements in list into separate documents. So if you have 5 elements in the list, after using unwind operator, you will have 5 documents as a result. So let's think about this case. So it's actually better to show using an example in this case. So I copy this first part first here. So let me put this here. So basically I'm adding a sample data into blog collection. So there's one document here. So user is key, post is hello world, and let's say that this post received several comments. Basically it's a kind of a blog architecture. And the comment is a list because there are 2 elements. First element is embedded document written by user Tom. Text is a nice post. Second element is similar, written by user Jenny. Text is cool, like this. So that's it. And we want to find all the comments made by Tom. So in that case, we have to perform operation on each element inside this comment list. So in that case, we can utilize unwind operator basically. So let's try this. So first of all, what I'm going to do is that I use the project operator first to select only those parts that I need, which is comments, because I don't need any other information here. So I only need comments. So this is actually quite important. So this is one of the things like I mentioned briefly earlier. So the reason sometimes we use a project operator is to reduce size of documents we process in the aggregation. Because if you have to process bigger documents, it will take more time basically. So to reduce speed, to make your code faster, we first select only part we need. So in this case, we don't need the user, we don't need the post, we only need the comments. So I use the project operator to select only comments from the document. And the second operation I'm gonna do is unwind. So I use unwind operator here on comments field basically. So we only took the comments field earlier, and I want to use unwind operator on the pre-existing comments field like this. Then basically after using unwind operator, each element in the comments list will be separate documents. So we will have 2 documents for each comment basically. And then the last part is using the match operator. So here we will use match to find the user information is inside the comments. So comments dot user. So it's embedded document. So we have to access the embedded document, and the value should be Tom, like this. So that's it. So that's basically the aggregation code to find all the comments made by Tom in this case. So let me try this. Let me copy this, and in MongoDB actually let me try one by one of this code. So what it means is that, let's try the first part first. So what happened, let's just see what happened after project. So this is the original document as you see. So in original document we have ID, user, post, and comments as a list like this. So after we only use project, this is what will happen. So basically everything is the same. We still have a comments field, but now we don't have a user and post field. So those two fields are removed and we only have a comments field left here. And after that we'll use this unwind. So if we use unwind, basically this will happen. So we had two elements in the comments list and now it become two documents. And only one element exists in each of this basically. So the first document has a comments as an embedded document, user and text. Second document, comments as a separate embedded document, user and text like this. So the list became, so elements in the list became separate document. And now because each comment is in the is a separate document, we can perform match operation to find comment written by Tom. So if we perform this, now we see that there is one comment written by Tom like this. So basically in this way, using three operators, we are able to find the comment made by user Tom in this case. Okay, so this is what one of the students asked earlier. So there are some aggregation options you can utilize, like a sort operator, limit operator, skip operator, out operator like this. So sort operator, the format is simple. You can specify a field and 1 or -1. And after sorting this, if you want to sort more given that group, then you can also specify one more field like this. So it will sort documents based on the values of the field, and one for ascending order, one for descending order. And there's a limit operator. If you use a limit operator and specify number, it will return the first number of documents you specify as a result. Skip operator, it's also there. It will skip the first number of documents you specify in the result. And there's also out operator, which can be quite useful actually. So if you use your out operator and if you specify the collection name, the result of your aggregation code will be saved as a collection. So if you want to save your results, then you can use your out operator and you can specify collection name. So there are some examples here, exercise here, so let's do it together to save the time. So we want to find out top 5 city which has the largest population. So we want to actually do something, we want to explore data and we want to find some information. Then for this exercise 1, we can design this query basically. So again, we want to look at the city, but the thing is that across different states, it's possible there might be a city which has the same name. So we cannot just use city as an ID. We have to use city and state together as an ID in this case. So as I briefly explained earlier, we can use the concat operator to create ID in this case. So first of all, we have to calculate population. So we have to sum up the population on each city. So in this case, we have to do aggregation by using grouping. So we use the group operator first, and then we have to specify the ID. And ID, again, we can use the concat operator. like this. So we make a new group ID by concatenating city name and the state name like this. And then we have to calculate the total population of each city. So total population should be summing up all the population in each zip code like this. So there was the grouping. So basically in the grouping part, for each city in each state, we calculate total population by summing up all the population information. And then we have to find out top 5 city which has the largest population. So we have to sort. We do sort based on total population, and we sort by descending order. So the highest population will be shown at the first place, and then we use the limit operator to show only top 5 city from our data set like this. So that's it. So basically that's the sample solution for this aggregation exercise 1. So we use the group operator first to calculate population in each city, and then we sort, and then we only select top 5 city based on the population. So if I copy this, and if I perform this query here, it will show you the results like this. Basically Chicago has the highest population, and the Brooklyn is the second, Los Angeles third, Houston, Texas is next, the last one is New York, NY like this, based on each city's population. So that was the sample exercise, and let's look at the next one. And let's try about this one. So find out population of the city Chicago in state Illinois. So we can actually use the similar information as we made earlier. So let me copy the first part here. At this time, we want to find population in a specific city. Then, as earlier, we can use the grouping operator first. So that we can calculate total population on each city, and then we can use the match operator to find information on Chicago. Like this. So that will do, right? That will the job work. That will do the job done, because we calculate total population of each city from our data set, and we'll use the match operator to select information from Chicago. So let's try this. So if we try this here, the results will be like this. So we find something. We find the total population from Chicago. So it works. But there is a problem actually in this code. So it works. So in terms of whether the job gets done, there's no problem. But this code is not efficient. So that's why I put the naive here. So if you design code like this, actually it's really not good in the reality, especially when you have a huge amount of data in your database system. The problem is this. You only need information from Chicago, Illinois. However, you are also making group for other city, and you are also calculating total population of other city too, even though you only need the information from Chicago. So you are calculating population of other city even though you don't need them. So you are spending some time for the information you don't need actually. So when you have a lot of data, actually this kind of a code will slow down the process of the system. So in this case, there's a better way to calculate this information. So what we can do is that instead of using group operator first, we can use the match operator first to filter what we need first. So what we need is this. We can use the match operator, and we can select only the documents inside the CD. CD Chicago. And state. Illinois, like this. And then we use the group operator to calculate and sum up all the population. Yeah, like this. So if you do this, basically we are changing the operation. So earlier we had a group first and match later. In this case, we have a match first and group later. We simply change the which operation to be performed first. And by matching operation, we'll select this document first, and then we'll calculate simply total population based on those small number of documents. So we copy this and put it here. Then it will give you the same result. Oh, this is not defined. Oh, I see. So it's the existing field. So I cannot use it like this. I have to follow the MongoDB rule by using double quotation, $, and double quotation like this. Okay, so let me try. Okay, so it gives you the same results basically. So this is smart code because you filter first, you select a small number of documents, so you need to do less calculation to get the results.
Why your first offer, the first answer for the same result, you can't less or you can't take come more marks for the second offer?
So sorry?
What if we provide the first this one
Yeah.
for the exam in the exam?
Oh.
If the marks same or you will give more marks?
Oh yeah. Yeah, actually that's yes. Yeah, because in the relational database part, actually it doesn't matter because whatever you use, the speed is almost identical because they always use join. But when it comes to the big data processing, the reason we are using this big data technology and we are learning this kind of thing is because we want to make things perform faster, and we have that kind of mindset. So if you, in the exam, if you make this query like this, slower query, then it gives you the solution, right? So you have the partial mark, but it's not the most optimal way. So you will lose some points in that part. Yeah. So you have to think about how to make the operation to be performed fast as possible. That's the important part actually. So that's why big data part is actually more complex in some way because you have to think a lot of like different things. There's no like structured way but there are many different ways you can choose, and depending on what you choose, the speed and the efficiency varies actually. And that's actually very important because in the practice, many people utilize a big data system just as it is, and sometimes they complain that they don't get any speed benefit because they are not using it in a correct way. So yeah, so this is basically what I wanted to point out. So here is just some summary of those difference. So when I did like a speed comparison multiple times, basically this is what I get. So smart aggregation code was almost 4 times faster than naive aggregation code in average. So it's much faster in the real world. What happened is this: in the smart code, documents were filtered first by matching. In naive, all documents were used to calculate the group values, and then results were filtered later. So that's the main difference. So to speed up aggregation, you have to think about preparing less document and preparing less size of documents. So those two are important to increase up the speed. So always filter first. That's important. If you are able to filter first, do it first is important actually. And okay. So what I want to talk, so basically that's all about the MongoDB demo, about the query, and yeah, I feel like there's some problem. Okay, let's just do this. So what I want to talk about now is map reduce concept, more about the conceptual thing. Actually, you may have heard about the map reduce concept. So map reduce is basically a programming model in the big data. So it's used. This kind of concept is used quite many times across a different big data system. So it's the model which supports parallel and distributed algorithm on a cluster. So that's the main concept. And the map reduce, by definition, the map refers to a part that performs filtering and sorting, and reduce refers to the part that performs a summary operation like count, sum, average. So combining these two together, we call it map reduce. So it's when you hear this, like filtering, sorting first and do summary operation, it sounds like aggregation. Actually, it is. So map reduce is made for aggregation operation. And usually map reduce operation happens like this. So you have input data, basically big data, but it's difficult to handle this big data in one server. So we use a parallel distributed system. Then this big data will be split into many different parts. So you have a part 1, part 2, part 3 of big data. And there's a map function on each server. In each server, they will perform map function on each part of data they receive. So by doing map operation, it will group the data into different group. What it means is that earlier when we do aggregation, when we calculate total population of each city, basically the city was ID. So in the map reduce function, it's the same. You can specify the key. In this case, if the city is a key, for each server, the map function will split this splitted data into different group based on the ID field. So for the same city, the value will be distinguished like this. And they will be combined together from different server. So in the first server, for city New York, there are multiple population information, and city Chicago, there are multiple population information. So second server, same. For these data, they will divide into different group. For the third server, same. Based on the part of data, they will divide those data into New York data, Chicago data like this. And then we'll merge it from multiple server. So these separated data, here there's a New York part, here there's a New York part, then we combine together and put it together here. Same for here, Chicago data will be combined together and we put it here. And then we do reduce. Reduce is calculating and doing aggregation. So we sum up all this population information into one value. So that's how we do aggregation by reduce function. And that's the basic framework of the map reduce. So it's similar to the aggregation. The only difference is that we are able to utilize multiple server in this case. So this is example, map reduce operation example. So again, we have zip code, population, state like this. For New York another zip code, for Illinois a certain zip code, for California certain zip code like this. Then by doing map reduce, what happens is this. By utilizing map, we are combining those data from the same key field. So if key field is a state, for California state we have a value 5,000 from here. For Illinois we have a value 3,000 from here. For NY we have two values 1,000, 1,500 from here and here. So we put it together. So for each key we combine, we list multiple value. Basically we are making group. That's the map. And when you perform reduce, the information will be calculated. CA 5,000, IR 3,000, NY sum of these 2,500 like this. So that's a simple example of how the map reduce framework actually operates. So if you use a map reduce concept, actually it works very well with the big data system because of this. This is what I kind of briefly talked to you last time when I talked about the introduction about the big data. So basically, when a user tries to process a big data, we can split them into three different parts, A, B, C. So A is stored here, B is stored here, C is stored here. And we perform operations separately by map reduce. So we do operation here separately here, and then we combine the results together, and the final results will be sent back to the user. So combining map reduce concept into the distributed system, actually we are able to utilize multiple servers that we can increase the speed of the operation. So this is a kind of a benefits of using map reduce with a parallel and distributed system in the real world. So in the MongoDB, there's an aggregation function, but you can also actually utilize a map reduce too. So here is some example here, how you can actually code map reduce function in the MongoDB. So map reduce part will not be in the test, but it's quite useful concept. So I want to show you here, so you can try this later. So basically, you have to define map function and the reduce function first. So what map will do and what reduce will do. In the map function, you have to basically define what will be the key and what will be the value you will gather together. So in the map, I define the function, and here I use emit function, and the first parameter in the emit function will be the key. So I use this .state. So this means each of the document. So I use this to refer to each document in the collection, and I use state field as a key. So for each state, I want to do something. So that's the key grouping variable, and then I specify the value. What kind of value I'll gather together? In this case, population field. So I specify this population like this. So that's how I define map function. And in the reduce function, here is where you define how to calculate information for each group. So in the reduce function, you specify key parameter and value parameter like this, and then you use return to return the results to the user. And here you specify what kind of operation you want to do. In this case, I use array.sum. Basically, it's JavaScript code. And here you specify value. Basically, for each key, all these values, I want to sum it up. So I want to have this total population for each state. That's what I mean by here, using reduce function. So once you code and define map and reduce function, you can use this code here. So db.cd, you specify the collection which has this information, state and population. And I use map reduce function here, and I specify map function which I made, and reduce function which I also made. And here I can specify query and some rules basically. So query part, I specify everything. Basically, I want to utilize all documents in my collection, and I use the out option to save the results from map reduce into state collection. So let me try this actually. Let me show you how what will happen if I try this in MongoDB. So if I perform this, then yeah, so function made, this function is made and it's performed. The result, it says okay. And if I, and as a result of map reduce function, I used this option out state. Basically, my result of map reduce will be saved in the state collection. So if I refresh test database, now there is a state collection created. And if I look at documents, basically these are the results of the map reduce. So I get the same results as aggregation basically. For California, population is about 29 million, Texas 16 million, something like that, New York 17 million, Illinois 11 million, something like that. So I can calculate total population of each state using map reduce function too, in this case. So again, this is how aggregation works in the MongoDB. And as you see, aggregation is very similar to the map reduce concept actually. So in MongoDB, they actually recommend to use aggregation because they made it in a better way in their sense. So we have a match stage, which is a filtering stage. Basically, it's here, and we have a group stage, which does grouping and calculating aggregation, which is similar to map reduce. And if you use map reduce in MongoDB, basically it will work in a similar way. So it's another example of how it works based on the map function and the reduce function, like this. Basically, it's this. So here, in aggregation function, the group operator will do all the calculation and the filtering. In the map reduce function, map function will do filtering and gathering, and reduce function will do calculation. That's the main difference.